Hi, my name is Corbin Rapé, and I am taking algebra with Mr. Fies. And Mr. Fies has given us this situation to learn about Newton's law of cooling. The situation reads, just before 7:30 p.m., students enter the classroom to find Mr. Fies dead. At 7:30 p.m., the temp of his body is 80 degrees, while at 8 p.m. it was 75 degrees. If the room is kept at a constant 70 degrees, what was the time of death? So he then goes on to give us what Newton's law of cooling is, which is T of T, which is the temperature at the time, equals T ambit, which is the temperature of the room, plus T object, which is the temperature of Mr. Fies' body, minus T ambit, which is the temperature of the room minus the object, times natural log of K, which is a cooling constant, times time. So the first part of this question asks us to solve for K. So to solve for K, we know the temperature of the room. The temperature of the room is kept at a constant 70 degrees. We know the temperature of the object at the time of discovery was 80 degrees. And we know the time. So every 30 minutes it drops 5 degrees. So we can go on to say that 5, which is the amount of degree it drops every 30 minutes. So this is what it just defined as. 5 equals T times 30, which means it drops 5 degrees every 30 minutes. And then we go on to add the rest of the information that we know. So it's 70, which is the room temperature, plus 80, which is the temperature of the body at the time that we found him, minus the temperature of the room, times E, which is natural log, minus 30K. So we come out with this. And then if we go on to solve it, we get what we, oh goodness, paper. So we would first do, we would subtract 70 from each side. So we would get 65 equals 10e to the power of negative 30k. We just subtracted this and we put it on to like e. And then we would go on to divide by 10 to get rid of the 10, so we just get the e to the power of 30 minus 30k by itself. So then we'd get negative 6.5 equals e minus 30k. And then since e is the natural log difference, so to say, we can just take the natural log of both sides to cancel out the e, and then we just have on the left side of the equal sign a natural log times negative 6.5. So before we solve all the natural logs, we just want to cancel out the e and get this by itself. So we would get this by itself, and then just to get k by itself, since we're solving for k, we divide by negative 30 on both sides. And since you can't have a natural log of a negative number, and you have a negative number in the denominator as well, you can cancel out the negatives to get k equals 0.6 or 0.1, and he said round to the nearest tenth, so we rounded it to the nearest tenth, which is 0.1, but we will use 0.06 because it's a more precise number. So moving on to the second part of the problem. The second part of the problem asks us to find the time of death to discovery. So what we know is a normal person's temperature, body temperature around, say, a person who is not sick, a person who is not exposed to extreme temperatures, has a normal body temperature of 98.6 degrees Fahrenheit. And when we found him, he was 80 degrees. And we discovered that every 30 minutes, his body temperature drops 5 degrees. So we can go on to solve for this. So if he was discovered at 80 degrees, we can subtract that from 98.6, which we get 18.6. So then we would take the 18.6 divided by 5 to get 3.72, which is about the amount of time, or how many 30 minutes we would have to go back in time to solve for the elapsed time from time of death to discovery. So then once we do that, we would take 30 minutes and multiply it by 372 to get the amount of time that has elapsed between the time of death and his discovery. So, and in this problem he said round to the nearest tenth as well. So we got 111.6 minutes. So then when we round it, we would get 112 minutes times has elapsed since the time of death to the discovery. So then last and final part of this problem asks to define the time of death that we estimated. So we would estimate the time of death to be 6:38 p.m. And the only reason why we know that is because if we go from 7:30 to 6:30, it's an hour. So we can subtract 60 minutes from 112 to get 52. So then we can split 52 up into 30 minutes and 22 minutes. So then that was defined here. So we'd go back 30 minutes, which is 6 o'clock, which gives us 22 minutes. So then we'd go back 22 more minutes, which is about 6:38 p.m. And that is the time that we believe Mr. Fies had died. Thank you for listening to this, and thank you for following along with the problem that I have been given. If you have any questions, please let me know. Yeah, thank you. Have a nice day.